viewers, welcome to CEC lectures. Myself Dr. Preeti Jagani from Department of Computer Science, Aribhat College, University of Delhi. So in the series of database management systems, previously we have seen the topic of entity relationship diagram, which is ERD, and we have seen it in quite detail along with some of the examples. Today's agenda is about enhanced ER diagram, or we can also say it as extended ER diagram. So the short form for this is EER, as in enhanced ER. So basically nowadays what is happening is whatever data we are storing in database management systems is becoming actually complex, and because of these complexities more and more difficulties are arising when we are using the traditional ER model for database modeling. So that traditional ER model we have already seen. So basically ER model is actually a tool for modeling the database, and when we are talking about modeling the database, that means we need to look into the data. But nowadays data is becoming more complex as in, let us take an example. So here we have for example, let's say we have an entity vehicle and another entity, let's say we have car and truck. So vehicle can be called as we can say a generalized entity as compared to car or truck, because car or truck are actually vehicles, but they have their own specific features also. So this is just an example I have given, that what kind of data we are actually going to store. That means there is some relationship between this vehicle and car, and also vehicle and truck. So this is giving we can say rise to the need of the modeling, or we can say complex modeling, which is much extended or much enhanced as compared to the traditional ER model what we were actually doing till this point. So basically we need some tweaking in the traditional ER diagrams, which is about enhancement of existing ER models in order to make it competent enough to handle the complex applications and these complex modelings. These advanced database modeling tools, which are extended ER diagrams, are actually very similar to the regular ER diagrams, except some we can say additions to it or some enhancement to it. But the advantage here is, or the property of extended ER diagram is that they represents the requirement and complexities of the complex database. So if we want to we can say list down whatever the extra points or whatever the extra things which cannot be represented in a traditional ER diagram, while we need extended ER diagram for that. So we can list them down as, so basically we know that ER diagram can be is a diagrammatic technique for displaying these features or these attributes or these we can say qualities, these characteristics. So what are these things? So one is a subclass and superclass. So your enhanced ER diagram, EER, is having facility for depiction of subclass and superclasses. Apart from that, it is also having a facility for showing the specialization and generalization. It can also accommodate union or categorization, we can say, and it is also going to kind of we can say take aggregation, display of aggregation. So subclass and superclass, specialization and generalization, union or category, and aggregation. So these are the four kind of we can say features for which we need extended ER model. So let us try to see what are actually these. So let us take the example, or let us try to understand the first one, which is about subclass and superclass. So if you can see about this subclass and superclass, or they can be also called as subtypes and supertypes. First of all, let us mention that what actually these subtypes and supertypes are in case of a database management systems. So when we heard the name, when we are hearing the name subtypes and supertypes, or maybe subclass or superclass, the first thing which comes up in our mind is about object oriented programming thing. So in object oriented programming we have classes as subclasses and superclasses, but here if we talk about database management system, or if we talk in terms of ER modeling, your subtypes and supertypes are actually kinds of relationships which cannot be kind of, we can say, depicted using the normal traditional ER model. So we need EER for that. Now super type is basically, we can say, generalization of one or more subtypes, while a subtype can be called as a specialization of a super type. So we have a super type, then if we want to specialize it, then we are going to get a subtype, or it could be vice versa. We have a subtype and we want a generalization of it, then we can have a super type. So basically here one entity is a subclass or superclass of another entity. The example which goes very well here is about that vehicle which I was just taking. A vehicle could be a super type, while a car, truck or motorcycle can be its subtypes. Now the point is, how are we going to represent these subclasses or superclasses in terms of database management systems? So as I have told you, subclasses are specialized classes and superclasses or base classes are, we can say, generalized classes. Now in order to represent this kind of relationship, we have is a analysis, is a is is, then a dash, hyphen, and then a. So for example, we can say laptop is a computer, or clerk is a employee. So for example, we talk about a university database. So in that university database, till this point we have taken very a large number of examples of university database in which we have considered only the faculty members as employees. But actually in a practical real life scenario, we need to have non-teaching staff as well. So clerk is also going to be an employee in a university database, in a university system. So university system is having with this specialized class of employees, it is having with this generalized class of employees, it is having a specialized types of faculty members or clerks. So faculty member and clerk both are, when generalized, we can call them as employees, but if we want to get into the specification, that can be teaching staff and non-teaching staff and so on and so forth. So here we can say clerk is a employee, or even your faculty is a employee. So here employee is a generalized class, while others, which is we can say clerk and this faculty member, are its subclasses. Now the point is, what kind of subclasses we are going to have, what kind of superclasses we are going to have in a database, and how are we going to represent them. So for this, let us take a look at the figure which is given on the screen. So here we have an employee superclass, or this is actually an entity which is named as employee, and the attributes which this employee is having, or this employee entity is having, and you all are aware that entity, when comes into real life practice, is generally represented with the help of a table or with the help of a relation. So this relation is having three attributes. One is ID, another one is name, and third one is salary. And here we have shown three rows. So ID 1001 with name as A and some salary, 1002 with B and some salary, similarly 1003 with C and some salary. Now this A, B and C are actually employees of we can say different type. So this 1001 is employee of, let's say, is a clerk type. Another one, which is 1002, is a lab assistant, and 1003 is kind of an engineer. So here when we are going to have the specialized details of these employees, we can have their ID and the department also. So, department is going to be different for lab assistant, for clerk and engineer, and so is ID. So, these type of scenarios are going to be, these type of scenarios, if you can witness here, are very, very common when we, when we are dealing with a database management system. Now, this situation is, if you want to, see this in the form of an ER diagram. So, here you can see that employee is having, which is at the bottom, employee is having, name, salary and ID, while it is having, three more entities associated with his. One is clerk, another one is lab assistant, and third one is engineer, with the ID and the department as their as the attributes of clerk, lab assistant and engineer. So, this is, this is how we can, understand the subclasses and superclasses, or we can say, we will be also covering generalization and specialization soon. So, coming to the specialization and generalization, as we have just seen subtypes and supertypes, or we have seen subclasses and superclasses. So, this process of creating the subclasses out of a given entity type is called specialization, and the reverse process of taking two or more entity types and clubbing them under a common superclass is called generalization. So, if we are going from child class to parent class, that is generalization, or if we are going vice versa, that is from parent class to subclass, that is what parent class to child class, that is what you called specialization. So, specialization and generalizations are, something which your extended entity relationship diagram wants to implement. In order to see the formal definition of generalization, we can say it is a process of generalizing an entity which contains the generalized attributes or properties of generalized entities, and it is a bottom up process. So, for example, let us say we have, previous example we have also seen the car, truck and motorcycle are three sub entities, and these three sub entities can be generalized into one super entity or one super class, which is named as vehicle. And specialization, if we can see, is actually we can say reverse process of generalization. That is the process of identifying the subsets of an entity that share some different characteristics, and it is a top down approach in which one general entity is broken into some specific low level entities which are having different characters. So, for example, vehicle, when broken into the entity of the class, then entity of the car, then entity of the truck and the entity of, let us say, motorcycle. So, this is actually, we can say, a specialization. So, how this specialization and generalization is going to be depicted in the in an extended ER diagram with the help of an is a relationship. So, here you can see we have one vehicle, and in the top down approach we are kind of, we can say, specializing it. So, vehicle is a car, vehicle is a truck and vehicle is a motorcycle. Similarly, if we want to go towards generalization, where in this example the generalization would be kind of generalizing car, truck and motorcycle as vehicles, because all three are vehicles. That is going to be a bottom up approach, we can say, that is car, truck and motorcycle will be clubbed together and then combined to be called as a vehicle. Please notice the representation here, which is given on the screen, in which this triangle shape is used for representing the term is a. So, this is going to give you kind of, we can say, a symbol to be shown for is a relationship. So, vehicle is a car, vehicle is a truck and vehicle is a motorcycle. So, in in the in this type of scenario, if we want to depict this is a relationship, the symbol which we will be using will be a triangle. So here we have seen two things. One is what is subclass and superclasses. Then these creation of subclasses or dealing in subclasses and superclasses is actually seen with the help of the processes of specialization and generalization. So two of the things or two of the points which are to be depicted using extended ER diagram was subclasses and superclasses along with generalization and specialization that we have seen. Now coming to the next one, which was about the category or union. So category or union, say we can in order to understand this category or union, which is one and the same thing, we can say it is a relationship of one super or subclass with more than one superclass. So for example, uh, here we can see three entities. One is owner, which is a subset of two superclasses, which is vehicle and house. So vehicle is also having is also going to have an owner, and house will also be having an owner. So owner here is, we can say, is the subset of these two superclasses, vehicle and house. So basically if we want to depict this union or category, we can use the circle symbol along with the letter U written in between, as we have seen on the as we are witnessing on the screen, that is vehicle and house are connected to the owner using a circular we can say symbol in which U as in union is being depicted here. Apart from this union or category, we also have the facility of aggregation. So aggregation is something which represents the relationship between the whole object and its component. And this extended ER model or enhanced ER model allows for the creation of an aggregate entity that represents a group of entities as a single entity. So we will be taking kind of, we can say, some 3-4 entities in the upcoming example, and that group of entities will be represented as a single entity. That means all those 3 entities are actually we can say aggregated in the form of a single entity, and this aggregate entity has its unique attributes and its own relationship. So this aggregation is about representation of relationships between a whole object and its components. Let's see how. So let's say we have a ternary relationship which is about works on. That's a ternary relationship, and when I am saying ternary relationship, that means 3 entities are involved here. So one is employee, another one is the branch, and third one is the manager. So employee, manager and branch are 3 entities which are connected with the help of a relationship named as work on, and as relationship is having 3 entities, it is a ternary relationship. Now how are we going to model this situation is, the best idea here, the best idea here could be aggregation. In order to model this situation, the relationship set which is works on is a higher level entity set, and such an entity set is treated in the same manner as any normal other entity set. So we can create a binary relationship between binary relationship manager between works on and the manager to represent that who which particular employee is managing what kind of task. So here if you can see, we have 3 if we look at the entities, we have 3 entities. Initially we are having 3 entities, one is employee, another one is branch, and third one is the manager. So one relationship between one relationship which is about the managers is created from manager, you can see its connection to branch, and this also it is also having the earlier relationship uh, which was named as works on, and that particular relationship was having three entities: employee, branch, and manager. So these employee, branch, and manager are, we can say, uh, basically we want to model this ternary relationship into with the help of extended ER diagrams, and relation modeling of these type of situations is actually not available when we talk about traditional ER diagrams, while these facilities are available in a extended ER diagram. So, subclasses and superclasses, the connected feature there was specialization and generalization. Then we have seen category and union, category or union, and we have also seen aggregation. So, apart from this, one feature which can be depicted in extended ER diagram is about inheritance. Inheritance as the general concept similar to that of that object oriented programming paradigm, that is a mechanism that allows subtypes to inherit the attributes and relationships from the supertype. So, when we talk about classes, we always say the inheritance or properties of inheriting members from their supertype. So, here in terms of database management system, we will say that uh, you know uh, subtypes, the inheritance is a mechanism which is allowing subtypes to inherit attributes and relationships from the supertypes. So, supertypes here are entities, and so is the subtypes also. So, this actually means that any attribute or relationship defined for a supertype can be inherited by all its subtypes. So, these kind of we can say representation facilities are also available in your extended ER diagram. Apart from that, the constraints. So, constraints as in we can, examples of constraints include cardinality constraints, which specify the number of relationships that can exist between entities. There could be participation constraints which specify whether an entity is required to participate in a relationship, whether it is required to participate in the relationship totally or partially. So, this extended ER model allows for the specification of constraints that must be satisfied by entity and relationship. So, apart from inheritance and the other characteristics which we have seen earlier, the constraints can also be we can say depicted properly with the help of EAR model. Apart from that, multi-valued, there are facilities which are available in the extended ER model about showing multi-valued attributes and about the display of relationships with attributes. So, extended ER model allows an attribute to have multiple values for a single entity instance. For example, a person entity may have multiple phone numbers. So, how are we going to represent that this is available in extended ER? Also, there can be some relationship between the entities, and these relationships are going to have their own attributes. So, these attributes can describe the nature of the relationship, or they may provide in additional information about the relationship. So, that relationships with attributes can also be we can say represented very powerfully in extended ER diagram. So, in order to conclude in this lecture, we have seen about what actually an extended ER diagram is, which is a flexible way to model the complex data relationships. It is actually an extension of the traditional ER diagram that includes additional features in order to model, or in order to represent the complex relationships between entities more accurately and more precisely. And what are the additional features that we have also seen in this lecture. Here is a list of references which is being used for the preparation of lecture. Thank you for a patient hearing. I'll see you in the next lecture. Till then, goodbye. Thank you.